All right, folks, in this video, we are starting on page 5 in your practice set, and we're looking at this second problem. So first, we are going to do a sketch from our calculator. So when I type this into my y equals, what do I need in that denominator? We have to enclose our denominator in parentheses. So folks, anytime you have a binomial either on the top or the bottom of a fraction, so for example, the next problem would need parentheses on the top. You have to trap it in parentheses. So that's really important. Otherwise, your graph is going to look different. Now, when I hit graph for this one, all right, I am not seeing a very good indication of what this graph looks like because I am still zoomed out from that last problem that we did zoom fit. So you can see that there's not even any tick marks on that y-axis. That's how zoomed out I am. So I'm gonna go and hit zoom. And then option number 6 is zoom standard, and that recenters me around the origin. And I've got this funky looking graph. So we're gonna go ahead and sketch what this graph is doing. All right, so there's my x and y axis. Here's this wide function piece. And then I've got this function piece and this function piece. Oop. So folks, before we get into the domain and the range and some of the key features for this, I want you to just look at how we are leveling up and leveling down at this point, and leveling down and leveling up at that point. Based on what we did in the previous chapter, what does it look like we have at those points? It looks like we have a vertical asymptote and another vertical asymptote where my function is leveling off. So folks, as we can see from our calculator sketch, it looks like this is happening at x equals -3 and at x equals +3. And if you look, what happens if I plug in 3 and -3 for x? 3 squared minus 9 is 0. Oh no, we can't divide by 0. And -3 squared is 9 minus 9. Oh no, we can't divide by 0 again. So this is why I have asymptotes here, because x cannot be equal to -3 or +3. So that's our first important key feature. Our next key feature is that it kind of looks like our graph is leveling off here as well. So it looks like I'm kind of leveling off almost like an exponential function at 0. And we're going to try to figure out how we can figure out if there is a horizontal asymptote there using our calculator. All right, folks, so let's go ahead and see if we can use this information to figure out our domain and our range. So first, my domain goes all the way left. I'm going, and then I have a break at 3. So my domain will be -infinity with a break at, -3, not +3, with a break at -3 because of the asymptote. Now, because there's an asymptote there and we don't actually get that value, we use a parenthesis. Union notation, my next interval starts at the asymptote again from -3 to +3. Parentheses around both of those because, again, I'm not getting a x value there. Union notation one more time, and then my next interval starts at 3 and goes to infinity. So what is breaking up my domain is the vertical asymptotes. Now for my range, this is where it gets kind of tricky as well. My range, remember, I don't have to state a different range for every piece of the function. It's all about the y values getting covered by my graph as a whole. So where do my y values start? They start from the bottom up at -infinity. But where do my y values end? It looks like I have a definite endpoint here at this relative maximum. Now, why is that a relative maximum? Because other points get higher than that one, but it is still a peak of this little curve that we have. So it looks like my y values stop at that maximum and then start back up again at that, what looks like a horizontal asymptote. So folks, before we go any further with this range, we're gonna see if we can find that point. So on our calculator, we're gonna go to second trace, select maximum. We're going to go to the left of that point, to the right of that point, and press enter. And oh boy, I love this. Your calculator shows negative 1.139 e to the negative 7th. Folks, anytime you see that e to a negative number, you can just assume that that rounds to 0. So a relative maximum at 0. And then the y value is at negative 0.3 repeating, which would be a negative 1/3. Ooh, I really wish I hadn't written that point in that tiny little spot. So negative 1/3. So a relative max at y equals negative 1/3. So I'm not going to write the coordinate there. So y equals a negative 1/3. And if you want, you could say at x equals 0 if you wanted to. So our low or our high point there, our relative high point, is at negative 1/3. And this is helpful to us because it shows me that negative 1/3 is where those y values stop. Now, because I am getting that value, it's a definite vertex point, and that y value is included, we use a bracket notation. So I'm just going to write relative max by that so we remember that that's where that came from. Now I want to see where my y values start back up again. It doesn't look like there's anything happening between negative 1/3 and 0, but it does look like my graphs are leveling off there. Folks, if I just use the trace key and I start following my graph, left, 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 notice that my y values are getting closer, 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 closer to 0, but they're never actually getting there. So folks, if we trace on over and we say, hey, it doesn't look like I'm ever gonna get there, we can assume that there is a horizontal asymptote there. So we would use our union notation and state that our y values start up again at 0, but since 0 isn't included, we don't actually get that value, we use a parenthesis. So horizontal asymptote. And then where do my y values end? From 0, they go all the way up to infinity. Ooh, so that was kind of a messy one as far as the range goes. Next, it's time for our increasing and decreasing intervals. And actually, before we talk about that, I'm just going to reorient myself and do Zoom Standard. And I want to show you what happens if you try to find a minimum for this point, that interval. So folks, if I use the trace button, sometimes students look at this point and they want to say that that is a low point of the graph. They want to say that it's a relative minimum, and yeah, it's kind of like a vertex visually, but not a vertex in the same way that we have for like quadratics. Folks, if I say that that's a minimum, look what happens if I go left. I keep going down. So is this point lower than the nearby points? No. And if you say, well, maybe it's a maximum. If I go left, my graph starts going higher than that point. So it can't be a maximum, it can't be a minimum, so that point is nothing. However, if you try to find it as something and you say, hey, calculator, what is, or what are the coordinates of a minimum point there, and you press enter, what your calculator will give you is the lowest point on that interval we set. So here it's negative 4.2 something. If I do it again, and I go further left over here, now it's going to say, when I do my guess, that the minimum is this end interval. So it takes me there to -6. So if it was really a minimum or a maximum, it shouldn't be changing when I try to trap it. So that key function will always give you the lowest value on the interval you select, or the highest value if you're looking at maximum. So be careful that you're really thinking about a maximum and minimum being where our function switches from increasing to decreasing. And that actually takes us to the next part of this problem, where we are going to look at our increasing and decreasing intervals. So folks, I'm actually going to use my calculator for this. So as I move from left to right on this graph, notice that, I'm going to go ahead and engage the trace button. So hitting the trace button, notice that as I go from left to right, my y values are going up. It's increasing, 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 increasing. So on that whole interval, I am increasing. So my increasing interval would start at -infinity. And where does that interval end? At -3. So it stops increasing there because of the asymptote. So I'm increasing, and that x interval stops increasing once we hit that break in the asymptote. So looking at my next part, it starts increasing again from there to there. So this interval starts at -3. And where does this interval end? At that relative maximum's x value. So remember, increasing and decreasing intervals are x values. So we're looking at what the y values are doing, but we're reporting the x intervals. So this one stops at the relative max x value of 0 with a bracket because that point is included. And I'm going to go ahead and just write relative max by that. So notice I needed the relative max to find out where that range value stopped, that y value, and I also needed the x value to determine where the increasing and decreasing intervals are. Now, is my function increasing anywhere else? As I hit that maximum point and I go this way, my function starts going more and more negative or decreasing. Same with on this interval, it just keeps going down, 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 getting closer and closer towards the asymptote. So for my decreasing interval, we start at 0. That's where that relative maximum turning point is. And then we decrease from 0. Ooh, and I should have made that orange. I'm going to write relative max by that. So we start at 0, where the increasing stops, and we go from 0 to 3, where we have our next break at that vertical asymptote. With a parenthesis, since we don't actually get that value. Then union, where do I start decreasing again? At 3, at the asymptote, all the way to the right. So that would be 3 to infinity. And as I said before, between your increasing and decreasing intervals, you should cover the entire domain. So -infinity to -3, -3 to 3, so -3 is 0. We have a stop at 0, and then 0 to 3, so that's the whole domain, and then 3 to infinity. So we cover the entire expanse of our domain. So folks, again, different graph, different complications with finding those increasing and decreasing intervals. The more you practice, the clearer these definitions will become.